This is SciByte, episode 105 for October 15th, 2013. Hi everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast, live on a Tuesday and fresh on Wednesday mornings over at jupiterbroadcasting.com. And back from a technical outage, and here to bring you the science every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
So, what are we going to talk about today?
Today, we're going to take a look at exoplanet clouds, updating atomic weights, blasting on Saturn's moons, viewer feedback, story and spacecraft updates, curiosity news, and as always, to pick it back in history and up in the sky this week.
Well, since we missed a week, we have to double down, Heather, and I suggest just to you, perhaps we should start with the news. All right, what are we covering in the news today?
All right, astronomers using NASA's Kepler Space Telescope, which is now, unfortunately, not in the exoplanet finding business, but has plenty of back catalog of stuff, using that and the Spitzer Space Telescope combined have created the first cloud map of an exoplanet.
Like, so they know what they are mapping weather patterns and things like that? What is this? What does a cloud map give us? I'm not quite following.
It means they know where the clouds are. Now it's actually fairly stable, the clouds, so the weather would be fairly homogeneous, kind of the same.
I dig.
But they have mapped out, like, here are the clouds on this planet. In another part of the in way the distant distance.
That is kind of an unbelievable accomplishment, like that we could even do that.
Yeah. No, this planet was like one of the very first that the Kepler found. Like, it was one of the 5 in the first month. Just because it has a really short orbit. It's every 5 days, so they're able to catch that dip in the starlight at a fair, 3 times in a very quick manner. Now, this is about the same mass as Jupiter, but about 1.5 times its size, so it could probably float on water. But what they're able to do is they're able to take Kepler's light observations that say, kind of get a rough idea of, hey, here's the planet, here's the bright spots on the planet, here is darker spots on the planet. Like, okay, it's brighter in this western hemisphere, but that we just kind of say, okay, it's a bright spot. Is it clouds? Is it heat? Because the thermal infrared, light would come in this kind of the same way. Mm-hmm. But the Spitzer Space Telescope was actually able to detect infrared light specifically. So you'd be able to measure the temperature. So then they say, okay, well, we can use that to, they use that to get information from planets' atmospheres. So combining the two, they would say, okay, these measurements are kind of cool for a planet that would orbit so close to its star, but also too cool to actually be emitting light itself. Like, it's not a molten ball of something that would be emitting heat. So they're like, okay, it's definitely not a place that expect to see oceans or that kind of a thing. So they say, okay, there is a nice, clear, reflective, there is something there that's highly reflective, and they're looking at that as clouds. Now they have, 3 years of data in order to combine all this kind of this low resolution map of this telescope. And they're kind of using it to say, all right, light is bouncing off the cloud tops, and that's what we're kind of seeing. And we're actually looking at it, how it looks over time, which is fairly stable, actually. So like, okay, so the climate there is not going to be changing very much. But this is the kind of thing where they can use all these different telescopes. Like, the Kepler was very specific for one thing. It has a whole bunch of back catalog of data, but it's still there. The Spitzer Space Telescope was made for infrared, and for looking at atmospheres. Very narrow band of what it was planned to do. But combining all the data from these different telescopes that have, we're doing this and this. And that telescope's doing 2 main things, but combining them all together, we're able to really pull out all the data we can on these exoplanets. So much more than we would have thought possible a mere few years ago.
Mm-hmm. That's pretty incredible. I love how we when you look back at how we used to observe planets like through telescopes and it almost seems so primitive now, right? But back then it was so revolutionary. But even no matter how good they could have ever have gotten the optics, they could never have taken advantage of this mass collection and analysis of data that we now have the capability of doing with supercomputer clusters and just regular standard, computing that industry can afford. And it gives us like this huge advantage now at taking disparate pieces of information, combining it together into a solid narrative and being like, okay, this paints a picture here that makes sense to us. And I think that's that what's incredible about that is we are just so at the beginning of taking advantage of that.
Yeah, I mean, over, the course of me studying, this kind of stuff, granted, I've been focused on it for, however far back my memory goes. But I remember seeing, the point where it's like, oh my goodness, there are exoplanets, and then counting them in the single or double digits. It's like, oh, wow, there's 10. That's amazing. And they were like in thousands. And I could have never, what I thought, like in 10 years, there will be more than 1,000. I will be checking out the cloud cover.
Were you not watching
on
Star
one
Trek?
of them?
Well, that's true. Even, I never even considered that.
I saw there were, I was like, all right, we're going to keep, obviously, if we found one or two, we're going to keep finding a lot. But I was like, wow, the amount that we found in this time and checking out the cloud cover.
Yeah, that is true. Yeah. Yeah. Being able to see that kind of detail gives us interesting insight and it's kind of a neat thing.
Mm-hmm.
All right. Well, any other thoughts on that story?
No, just looking forward to all the different stuff that these telescopes can combine together.
Yeah. I'm sure we're going to hear more stuff. All right, Heather. Well, then let's take a quick moment right here to remind folks that one of the ways we support the SciByte program and all of the shows on the Jupiter Broadcasting Network is by our affiliate system. Now, you've probably heard me say it before. If you haven't, maybe you're new around here. And if you are, welcome. But if you need to know about something. It's important to us because it plays a big role in how this network operates. And at the bottom of our website, we have links down to our affiliate sites for Amazon and eBay and Netflix and Newegg and ThinkGeek and Best Buy and Mint and Audible, which is awesome. Great Android app. Syncs between your devices. So cool. Code School. And then we also have Chrome and Firefox extensions linked down there. They're way, way down there. You got to go way down there. And if you click, you've grabbed those Chrome extension or the Firefox extension, then you'll also get tagged for things like Woot.com. And we'll also do different country codes for Amazon and some of the other popular sites. Now, Heather has a fantastic pick this week. If you needed a suggestion, if you wanted to pick something up for yourself and support the network, Heather, Star Wars Clone Wars, the complete season 5. I didn't know you were a Clone Wars fan. Did I know that?
Oh, rabid. This season, granted, so sadly the last, but oh my goodness, there were so many good episodes. There is one fight sequence, like lightsaber fight sequence, that my husband and I were watching the television show. We got to that point. We're like, had to stop it, but take a breath, watch the last couple of minutes of the show. Then we went back and we watched that sequence at least 3 times that day.
Wow.
We're like, okay, we have to go back and look at that again.
Yeah, you know what happened to me?
And then we started noticing all the different intricacies and what's in the background and what's hinted here or there.
Yeah, so I watched the first season or so. I can't remember. I wasn't huge on it, and then I dipped back in later on. And I was really impressed. And what you just said there about the background, the level of detail and little things that are throughout the whole series is really enjoyable. It's fun to catch that kind of stuff. And they're able to do things that they remain within the confines of the Star Wars universe, but they're able to do things that you can't do in traditional movies, really. Like camera angles you could never do and things with the characters you could never do. It's super cool. So, and you have in here the multiple versions because you know how Amazon rolls. I would get it on Blu-ray though because it looks incredible.
Yep.
It really. I've seen it in HD and it really looks amazing.
Yeah, I've got all the other Blu-rays and that one. I'm impatiently waiting for it to arrive on my doorstep.
So what to see? It ships on. Well, so it's shipping now, right? It wasn't shipping last week, right? Is that what it was?
No,
but it is shipping
it was
now.
coming out next week.
Yeah, okay, so
coming out this week.
Yeah, it comes out on the 17th. So
yes.
Yeah, so that's just a couple days from now.
Yep.
Well, that's cool.
Pre-order, get it on the day that it comes out. Be gleeful like I am.
Mm-hmm. Yeah, that sounds like a good one, Heather. All right, well, there's our pick, and you can support the show and the network by taking advantage of those. We'll have a link to that in the show notes. And if you click that link, it'll be towards the top of the show notes that is automatically tagged for your country. And with that filed, it's time for the News Bite. What are we covering in this News Bite, Heather?
the International Union of Pure and Applied Chemistry has actually changed the official atomic weight of 19 different elements.
We can do that?
Now, don't forget, this actually happens every so many years.
Okay.
Yeah, it's not like, and it's very, very minuscule things. Essentially, every atom of an element, say silver, all have the same number of protons. Now, there are different types, like, they'll say silver 109 or silver 107. And that's talking about how many, the different isotopes of it. That's talking about how many neutrons there are, because there are different number of neutrons. And that will, of course, change the weight of an element. So what scientists are kind of doing, they're like, okay, we're going to say that all of these different isotopes of silver are, in various degrees, how much it are there. These are, there's very little of these kinds, so toss that out. Kind of average up all of the isotopes together to give an official, quote, atomic weight.
Mm-hmm.
So it's, like I say, it's very, very little. When you're talking about, like, I think the most is like 0.0088, change.
So it's a details matters kind of a thing.
Yeah, that's not something that everyone is really going to matter about.
Okay.
But
okay.
But I mean, it's one of those situations where previously they thought like, oh, this specific isotope of this was way too rare, but now they're like, wait, no, not as rare as he thought.
Oh, wait.
And because of all this stuff, I mean, silver in one part of the world is a different atomic weight than silver in a different part of the world. So it's not really changing a lot, but enough so that, I mean, any detailed, chemistry, we're getting more and more, further in technology. So there might be a study where they go, hey, that little bit of difference really changes the readings.
Mm-hmm.
It's like, for some of my chemistry, it's like everyone else is fine to do like 0.26. Me, for some of our stuff, we need like 0.26913. It needs to be much more accurate in order to calculate the precise details of our experiment.
I see. That makes sense. So I see how it could actually impact quite a bit.
Mm-hmm.
Yeah, okay. All right. Very good. Well, with that done, then it's time for the 2-Byte News. The band is extra staffed today, if that's, I don't know if that's what you call it, but yeah, they brought in some people from the street, and they're pretty good.
Oh.
Harmonicas, though, and I didn't even hear them at all.
Yeah, I know.
So what are we talking about in the 2-Byte News?
All right. Last Tuesday, it was very last-minute news. Still awesome news. The Nobel Prize in Physics for this year has been awarded to Francois Englert and Peter Higgs for the theoretical discovery of the Higgs boson particle. This is not this is sort of the, yes, we actually discovered it this year, and the discovery and the experiment that that provided, say, yes stamp of approval, here it is, that could be a different Nobel Prize in the future. But since that's sort of, yes, it exists, now they're going back in time and saying, hey, you guys said it's theoretically going to be there. This is what it's theoretically going to be. Hey, it is. Good job for that.
You did it. Good job. We recognize you did that.
Yeah, because there was a lot of question because they can only give it to 3 entities. So there was a big, controversy about, hey, would they give it to those guys? Would they give it to, the teams who discovered it? Would they give it to the CERN, the giant?
Yeah, it seems like that conversation would go like this. Hey, did this guy discover the God particle? No. Did this guy discover the God particle? No. Did these 2 guys discover the God particle? Yes. Okay, they get it. It seems like that's pretty obvious.
Well, it's like, hey, I imagine there could be this thing that is a glass ball that makes light come out of it.
Well,
and then somebody makes it.
Okay, that's neat. It's not God particle neat, but it's neat.
No, but that's the kind of thing. It's like somebody thinks that this is going to happen, does a whole bunch of things and says, yes, I bet this is there. But then somebody actually goes through the science and the experimentation and says, hey, this is exactly what I had to do to say that exists, and it does. But
Very
yes,
good. Very good.
It was really cool.
Good for them. Now,
and it actually took an hour longer than they thought it would. they like stayed in seclusion for a little while longer than everyone thought. So they're like, what's going on? Of course,
Oh.
they won't say what goes on behind closed doors.
Oh,
And
maybe some
so
last
many
minute
years pass.
deliberations? No, really, you think?
Yeah.
Maybe. I got a question for you. I heard a
Okay.
headline that I thought maybe you could clear up for me because it just doesn't seem possible, Heather. But I heard that we have discovered plastic on a moon, and it's not our moon. It's maybe Saturn's moon.
Yes, it is.
What's going on?
Yep, I read a story that's like, or somebody mentioned me like moving Legoland to Titan.
Oh,
Of
jeez.
Saturn's moon. Yeah, so the chemical component that is that is just propylene, which is the kind of stuff you find in plastic containers, car bumpers, is actually discovered in the atmosphere of Titan. Now, this is specifically from the Cassini spacecraft that's orbiting Saturn. They're able to use their spectrometer instrument to take very specific infrared light to do this. Now, this is not completely brand new. Actually, there was some Voyager 1 data that said, hey, we recognize some gases here that are like hydrocarbons. So they said, that could actually be sort of propylene, but it's because it has a really weak signature. It's sort of a small data blip next to some really larger ones.
Okay, so they're like, okay, we note this, but we're not going to make a big deal about it.
It's like, we see that. Could it really be there? It's kind of in the noise of everything else.
I think that's
and
pretty
now we've
interesting.
actually seen that here. We're like, hey, yes, stamp of approval. Yeah, that really is there.
Well, maybe now we could start building our spaceships out of plastic, and then if we get damaged along the way out the solar system, we could stop by there to pick up some parts for repair. Just have a little factory. So now the
we
robot
don't know how
factories.
well plastic would fare against the heat of atmospheric reentry.
Well, here's I got it all figured out. What you do is you take some of these Wildcat running drones that we've been talking about for a long time on the show, like back in SciByte 62. We take one of these and we just put like a whole bunch of them out there on the moons mining this stuff for us, and then they bring it up to like some sort of carrier. What do you think? Is this possible, Heather?
Science is unsure.
All right. Well, we do have running robots, though.
We do. Boston Dynamics. Those are those crazy people. They come up with all these different robots. The ones that look like a horse and kind of stomp around and can keep their balance on ice. And they'd had one before that was like a cheetah, kind of running, except it was on like a treadmill and hooked up with a giant wire. Now, check the show notes for the video and or watch the video version. And this is running fast and it's free.
Yeah, so it seems to be going. Okay, so number one, no cord, no
cord,
no wire. It seems to be self-powered, or the motor now is built into it, and it seems to be going faster than we saw it last time.
Yeah, well, I think it's
16 miles per hour. I think is what is. So maybe that's what it was last time, right? I guess maybe.
I think it was a little bit faster last time, but it was.
Look at it recover! Oh my gosh, it just recovered from a massive spill like a pro.
Yeah, well, it was kind of gangly and on a racetrack before, and now it's just like free running down a road. It looks totally different, and it feels like I really don't want to be on that road with it chasing me down.
All you need is lasers on the back of this thing, and the robot apocalypse has arrived.
See, I knew you would be like lasers, and
yeah. Next, you're gonna tell me it has a jetpack and a reactor in it, and then I'm really gonna freak out.
Yeah, then it's time for the hills.
Actually, all kidding aside, that obviously there are so many practical uses for that.
Yes.
I'm really impressed just in the span that we've been covering on this show how far it's come. Like the first time you showed it, it was like this cagey demo where most of the components were outside of it. Then later on, there was one where it was mobile, but it was all wired into a power source. And now we're here. It's absolutely incredible.
Yeah, every time I see a story coming out of these guys, Boston Dynamics, I'm like, oh boy, what have they made now, or what upgrade have they made to one of their robots now? Because it's going to be crazy.
All right, Heather, grab your EV suit because this is either blowing the hatch or it's incoming viewer feedback.
Close.
That was close. Good news. It's feedback. Oh, what do we got, Heather?
All right. Last week, I got an email from the chat website email thing, and it was from Nogal saying, hey, I was in the chat room, and he said, he's been brought up a point that the ice caps were growing and everyone called him a nut. He's like, please help me with this conundrum. Okay, so right up front, I'm being a total wimp, and I'm not going to give you a straight up answer on anything about this because it's really a hot button issue. And when it comes to these kind of things, saying one thing, it automatically turns people off. They're like, this is how I believe, snap my fingers, turn away, walk away. So now there are obviously studies that say a lot of different things. I have test results to say that, depending on how I look at it, can say a lot of different things. But there are, actually studies, that are clearly show that perhaps the Arctic is decreasing, the Antarctic cap is expanding. So some studies say one is decreasing, one study said the other cap is expanding. There are studies about the thickness of the sheets. There's the National Snow and Ice Data Center has a big book, and they actually printed had a misprint that had a large error in one of their maps concerning one of the ice caps. That sort of got silently updated, so that added a whole other complication to the issue. So really, when it comes down to these kind of things, you really look for yourself. This is where science happens in your brain. Look for yourself, find out the different data, look at, hey, who is saying this? And then look to the people that don't agree with you and say, okay, the complete opposite side, what do they say? And don't just blow that off because it's those people, but really look at all the different data and kind of figure out how you feel about it. Look about who's writing it. And it's really bringing together all the science for yourself. And that is, for some issues, that is a really important thing.
I hear you, Heather. Well said.
We had another email saying, hey, have you ever considered doing from Matt? Hey, have you ever considered doing an episode on Chris's beliefs about nutrition and food? Okay, not giving you a straight up answer. Yes. Okay, so I talk a lot about science. And some of the science I talk about says, hey, science says this food is good for you. This something in broccoli helps your brain. Most of the medical stuff that I talk about is years in the future. I am not a dietitian. I cannot tell you what is good for you. Besides the fact, you could have different, how's your metabolism? What is your body doing? Are you have allergies? You know what? Milk, the good commercial, milk does a body good. No, it does not do my body good.
No, not for me.
Severely lactose intolerant, it would have made me highly sick.
So have you always been lactose intolerant?
Yeah, I was born. So as a kid, you go to a birthday party. There's a parent. Here, have cake and ice cream. No, thank you. They act like a crack dealer going, take the ice cream.
I know. Well, see, for me, cheese, I actually prefer salty stuff. So for me, it's cheese. It's so tempting. So last night, I had some jalapeno poppers with cheddar cheese in them. And I have been in so much pain all day from it. It lasts all day long. Even when I cheat just one time, it was harder for me because I used to just eat whatever I want all the time.
Yeah. Plus, science about what happens to your health, okay, no matter what anyone tells you, to some degree is what I call fuzzy science. Because you know what? Hey, this makes me healthier.
Mm-hmm.
What in the last 24 hours have I done? I have walked outside. I have breathed this. I have walked past all the trees that are dropping leaves on me. I've walked through things that look suspiciously like little snowflakes. I've eaten all sorts of different things. So it's like, what is affecting on you? So there are a lot of different things.
It's let yourself be your own science experiment. See what if it works for you, then maybe there's something to it. If it doesn't, and like Heather said, it's kind of the same thing with the climate change stuff. Is you just got to look at everything that makes sense to you.
Yep, and possibly include people with more medical knowledge than yourself. That's in that specific area. I like science, and I'll look up, what do I think about all these different type things, and what do I feel about these different type of diets. But there comes to a certain point where you have to say, okay, who do I trust? And where can I get that information? And do I feel like I need a one-to-one person saying, all right, here are the details about you?
There you go.
So
yeah, that doesn't really fit in this show too much.
Yeah, it's very, very particular. So send in all your viewer feedback. I have a whole bunch more that's in the back catalog, but realize sometimes I might take the wimp's way out. Not very often, But for certain issues, I may not fully package the science up with a nice little bow.
And if you want to contact the SciByte show, go to jupiterbroadcasting.com and click the contact link and then choose SciByte from the drop-down. And then put your message in there, and our robots package it up and deliver it via science tubes to Heather. How about that? All right, Heather, we'll then stand by because it's time for some updates. What do we got?
Yes, it is. Comet ISON. I also had some viewer feedback saying, hey, I remember you talking about that last year. What's going on with it?
What's ISON doing? What is it doing, Heather? What is it doing?
Yeah, this was supposed to be the comet of the century.
Oh, nice. That sounds like we need a jingle from that.
Yeah, don't get the jingle together. And I mean, at that point, I'm like, hey, I'm going to mention this. I'm going to wait a little while to see what happens. Because all astronomers know, hey, guess what? Say that wave arm thingy, and then also try to make sure that people know we could be totally wrong. We don't know yet. So, yeah, it's definitely not the comet of the century. It may be the comet of the year.
Okay. That's not the century, but...
No, it's still unknown. It's not even known really if it'll be anything spectacular whatsoever. But I mean, right now you need a fairly good telescope, one that's 8 to 12 inches in diameter. You need a dark sky, some high magnification, and know exactly where to go. But if you do that, go ahead and look there. It's not very bright. So if you're looking for it, I use what call astronomy averted vision. It's where you look just to the side of something because the center of your eye is best for color. Just outside of that, there's like a ring that's really detailed for black and white. So if you kind of look just off of it, you can use that vision right there to really pick up gray-white things. I use that a lot looking at astronomy stuff. So it's like, hey, I knew that. But, so there's some that say, there was one story that came out with a professor going, oh my gosh, wave hands in the air, run around like a chicken. It's breaking up. And so, saying, hey, this is data that I see and it matches up with data for other comets that have broken up and done nothing. And then other people came out and said, no, calm down. No, it's not being awesome. Now it's just, it's passing what they call the Roche limit. That's where, it will be passing the Roche limit at some point, which is where the gravitation of the sun will actually start mushing it up and possibly tear it apart. It has, because it's doing a flyby on the sun that's going to be fairly close to it. So we're going to see it head towards the sun. We'll see what happens. It is significantly dimmer than what we thought it would be. It's much less. We thought it would be much, much brighter.
Not the science show you were hoping for, Heather?
No, not the
you wanted a science show.
I
understand.
I wanted awesome. I wanted it to be across the sky and possibly visible in the day, but
with some awesome pictures to put in the show notes.
Yes,
that would make for an epic show. I'll give you that.
Yep. If you have a telescope and you manage to take a picture, definitely send it in. But don't feel bad if you can't, because this right now it is kind of hard to see. So we'll see in the future. It may be getting more. Still have some optimism about it. So it could be the best comet of this year, but we haven't really had a lot of good comets.
Okay, so the bar's low.
Yeah, the bar isn't that high.
Okay.
It could fizzle to absolutely nothing. It could break apart, as it whips by the sun.
Disappointment of the century.
Yeah.
Okay.
But so it'll be the next couple weeks where we'll get a little more data on the actual fate of this poor little comet.
Yeah.
So there will be more updates now.
Okay.
It wasn't worth much talking about in the interim until we got to a point that said, hey, now it's here. Now what is it doing?
So we kind of now just have to wait and see if it disappoints or if it manages to pull through.
Yes, and there's plenty of information in the show notes if you really want to try to find it. There's websites that show all the different new pictures and, how to find it, where to find it if you feel like trying to do so.
Good luck to you, citizen. Now, Heather, I don't want to freak you out. Just keep in mind, this is, a spaceship from the future planted here on Earth to do a science podcast. So I have a button here to push. This is either the subspace radicalizer or a spacecraft update. I'm not sure. Here we go. Up.
Oh my gosh.
It is, in fact, a spacecraft
Nice on the
update.
show. God.
And here I thought we were going to radicalize subspace. All right, so what is the spacecraft update?
All right, we got some private space travel people. SpaceX is back, and also orbital science. They're the other upcomers. They have the Cygnus spacecraft is another that they're able to do docking up with the space station and deliver over 1,000 pounds of cargo, food, clothing, water. We've seen SpaceX make, some deliveries. Now, orbital science, Cygnus spacecraft, they were able to make a delivery up there. They had, the first one was delayed a week, but the first time it happens, that first go around, something is bound to happen.
And this, I love that. So, the YouTube video is a little hit and miss, but I love that we have two different private space agencies, or whatever you want to call them. They're both posting their videos to YouTube. That's so cool. Yep.
Well, that makes sense for them.
Yeah.
I love the part that we have two different, private industries that are going, hey, buy our, backpack to the space station. We will deliver it. We're a delivery service.
Oh, jeez.
So, we as a country, the government may not be sending things up to the space station, but we certainly have businesses that are doing it.
Yeah.
So
Cygnus, how's that how you say it? Cygnus?
Yeah. Now, SpaceX is also getting ready to do its kind of a new rocket, the Falcon X.
Mm-hmm.
That actually was able to deploy the Canada's Cascade Polar Explorer. It had a satellite, a weather satellite, a couple other satellites that were there. So they're able to put things, a satellite in orbit. So we've got there can deliver things to the space station. They can put satellites in orbit for you. Now these are both, the government isn't, doing it necessarily. NASA isn't doing it, but they were started and developed by, small contracts saying from NASA, probably similar to the ones that my company does, except on a massive scale, where NASA says, hey, we want to do these kind of things. We'll give you a little bit of money if you can do it. And so we say, hey, we have this idea on how to do it. They say, we like your idea. Then you get money from them, you start up. And then for them, they'd say, okay, we've started up our idea. We've got, a baseline. Now we're going to grow and do other things. So now we've got, delivering satellites and delivering cargo to the space station. They've grown to this point.
Pretty awesome. It's a good spot to be in.
Yeah, I really like the private space industry. It's growing, fairly quickly. They have a lot of different, self-regulated things that have to happen. And of course, doing things with the space station or with NASA means they have to meet very specific, stringency.
Mm-hmm.
So they still have to follow the same strict rules, but
it's interesting. They almost, they really seem to be developing it at a blazing pace.
Yes.
Remember how we were talking about before they even had launched anything?
Yes.
Kind of unbelievable, really.
Yeah, I remember them going, we were talking about, hey, they're getting this ready. Oh my gosh, they're testing. Now, hey, they're getting ready to send the first one. Oh, wow, it's the first one. And now it's like, how many have they sent up now?
And now there's two of them
Not sure
doing
I remember.
It. Yeah.
Now there's another company doing it. And now they're sending satellites up as well.
Kind of awesome, in a way. Kind of awesome.
Yes.
All right, any other thoughts on that one?
Not yet.
Well, while we're talking about blast off and lifts off, should we go over and do a curiosity update?
We can do its older brother update first.
Oh, I didn't even see that. All right, let's do it. Do I have an opportunity? Well, how about this? I don't have a specific opportunity update.
That's okay.
Well, let's start with opportunity.
Everyone talks about curiosity, but opportunity is still chugging along. It's actually been discovered to collecting some really interesting new survey scans about where it is. So they're kind of able to improve the resolution of what's going on, using the data from the orbiter to they look down and get some really high res stuff about this area going, hey, we want to take this exact path because this looks like it has the most information we could get out of it. And it's actually beginning to make its first make a climb on the Solander Point. It's the first mountain it's ever going to climb. It's kind of the ridge of a huge crater where it is actually kind of landed. So now they're kind of looking at like, hey, on this slope of it, you can see there's various layers about where, all the different layers of sand and sediment were.
Mm-hmm.
And over the course of this, there's a little jut where they can sit on, or they're sitting on top of, and between one side of it and between the other, there are thousands, there are, well, should I say billions years older than those on the other side. So they're able to look at this huge range of data for geology. And they still got the arm. They can still extend it, take photos with the microscopic imager. They still have the alpha X-ray spectrometers. They can still take spectral measurements. So it's still got a couple of instruments that are very useful, and they're still being able to, chug along and get all this useful information. Now they're in a really interesting place to say, okay, it's on a hill is where it needs to be because it's getting ready for the Martian winter where it is. So it'll be, ready to go where it needs to, tilted so it gets the most bang for its buck out of the sun, out of the sunshine that's coming through its solar panels because it's solar panel powered. So we'll see how it goes. And as it reminds us that Curiosity is not the only rover doing science out there.
No. That's a good point. But while we mentioned Curiosity, should we just take a short jaunt over to the Curiosity rover, Heather?
Let's go.
A jaunt.
And liftoff of the Atlas V with Curiosity.
Yeah. Oh, yeah.
Touchdown confirmed.
Oh, yeah.
We're safe on Mars.
So what is what's going on with Curiosity? What's it doing?
All right. Over the last couple of weeks, we've been talking about how they're trying to gain more autonomy with the rover. Now it's got this new technique in placing its tool-bearing turret, they call it, on the robotic arm.
Okay.
So it's like the little arm to kind of give it a little bit more autonomy about how to place the arm close to where they actually want to be. So they're able to use it to say, hey, we want to go over to that rock. So the different, there's a proximity that they're able to sort of use as kind of radar to say, hey, how close are we to this soil or rock surface? So what the rover is now able to do is think for itself, say, I want to go over to that rock. Reach out and say, I'm going to stop, a foot away from that rock and wait for the scientists to catch up to me. Now, there is a lot of time that's saved just by saying, I'm going to get this close to that rock. That's, hours of data back and forth, days of having the team go, okay, tell the command to reach out forward a little bit more. Now wait for the information to come back. All right, now we have a new set of commands. Now we need to test the commands, make sure, are they okay? Okay, now send them on. So this kind of autonomy, like being able to sort of self-regulate its short drives to reach out its arm most of the way, so the engineers and the scientists will still be able to do the fine details and make sure it's not going to ram itself into anything. But it's able to save, hours and days of time. So we're able to do much more bang for our buck in science.
Very nice, and kind of a neat way to utilize equipment they sent it up there with that didn't, I guess, initially have the capacity for, but then they're able to add it on as it goes.
Yeah, so they just kind of be like, hey, this is used for this. Hey, now I think we can use it for, making the rover autonomous too. Hey, multi-purpose this thing.
There you go. Very cool. All right, Heather, you want to jump in the time machine? You ready to head back?
Let's go.
All right, close the door. Close it. Otherwise, it breaks the whole thing.
Yeah, I know. I don't like to do that sometimes.
You like my lava lamp?
Oh yeah, you bring in you used to have that. Yeah, you took that thing out for a little while.
I know. Well, it was getting warm, but now that it's winter out. All right, so this just a short trip this week. 24 years ago, October 18th, 1989. Heather, what happened this week in science?
The Jupiter orbiter Galileo spacecraft. It launched this week. Yay. Jupiter. I know. So it was released from the STS-34. That's the Atlantis orbiter way back in '89. And so it was pushed out, and they said, okay, it's going to use a gravity assist, which means it looped around Venus and Earth to give it an extra push to head out towards Jupiter. It was 6 years of road trip all the way to Jupiter. Now, it made a couple of, studies in between, Earth and Jupiter. So it did, dust stuff, magnetometers, various different detectors, but it made It also was able to catch 2 asteroids fairly up close. But its main mission was to study Jupiter and all its satellites, and it did that for about 2 years. And then it actually was able to release a probe in December of 95 and dump it into Jupiter's atmosphere itself to kind of take some, heat or temperature and pressure and various measurements as they kind of dove into the clouds for however long it was before it got crushed. And there was actually a little bit of debate on that. I remember going, hey, do we actually want to dump something man-made into Jupiter's atmosphere? Is that going to do anything?
Oh, interesting. We're going to go pollute another planet in a sense, but it's friendly pollution.
Yeah, it's science. All in the name of science.
Right, of course. All right, Heather, well, let me recalibrate the SciByte 2000 here so that way we can look up into the sky this week.
That's right. On Friday, October the 18th, if you go into the evening, you actually see the full moon. And you might be able to see that there's some shading on the moon. That is what we call a penumbral eclipse. It's not like the full eclipse. So it's just kind of in half shadow of the sun.
Cool.
So it might be a little bit dimmed. You might not be able to notice it. There's a couple in North America. The maximum will be at 7:30 p.m. Eastern time. For Europe and Africa, you're going to be looking at 2300 GMT.
Okay.
So just all over the place there to kind of see. On the planetary lineup this week, we've got Venus, if you catch Mountain Dusk in the southwest. Going to be moving slowly higher and higher in the sky over the next few weeks. And Mars is 3 a.m. local to you. It's moving high to the eastern sky, close to the star Regulus, which is a blue-white star. They've been hanging out pretty close to each other for a little while now. It's kind of an interesting pair because you can see the red-orangish color of Mars and the blue-light color of Regulus. And Jupiter, another favorite planet around here. You look to around 11 p.m. to midnight local time. It's going to be rising in the east to northeast and moving to the upper sky by the time dawn comes around.
Oh, fantastic.
And as a special aside, we've got a comet.
Oh, yeah.
Comet Iceline.
Yeah, of course.
It's going to be hanging out near Mars this week. Of course, you definitely need a telescope, like I said before, to view it. You can look up in the show notes, which I'm of the mind, theater of the mind, pointing upwards.
Oh, yeah. Well, this portion of the show notes is kind of at the bottom of the show notes.
Yep.
Yeah,
so you look up at the higher in the show notes, and we'll see that's where the details of how to view it are. But
yes, and if somebody were to get a picture of it somehow through their telescope, if they went over to that contact page, they can attach an image to the submission form.
Definitely. Yep. Definitely input visuals.
So Heather has all of that outlined in the looking up this week. So if I wanted to see when those planets were, or Comet Iceline, then you can go check that out over in the show. Or the moon. That's pretty cool too. So she has everything that she's covered outlined in the show notes with additional images, videos, and multiple references for everything covered. You can find that over at jupiterbroadcasting.com and just look for SciByte 105, where all of the good details are listed. And don't forget, you can join us live on a Tuesday over at 7:30 p.m. Pacific. Go to jupiterbroadcasting.com/calendar and it'll automatically convert it to your local time zone. Or you can grab our show on Wednesdays and snap that RSS feed and just get it automatically. Heather, thanks for the great show.
Thank you.
And thank you, everyone, for tuning in to this week's episode of SciByte. We'll see you right back here next week.